high-performance computing. Can you describe your offering in high-performance computing and how it can be used in perhaps electronic trading, if that's relevant?
Well, it's not just electronic trading. I mean, they're a big phenomenon, and they all, and actually, I think we had a customer speak here, Mark Jacobs from Bridgewater did a great job describing it. He said, look, our job is to instantaneously access data. It's got to be instantaneous, otherwise the data is out of date. That's the nature of financial transactions. If you're doing scientific exploration, data doesn't change that much, but financial data is changing all the time. And so if you say, hey, look, it takes us an hour to do a computation, that is of less value to us because you're an hour out of date with the information you use than say it takes a minute to do, or it takes 30 seconds to do, or it takes a nanosecond. I mean, it takes a small amount of time to do a computation. So in a sense, the key is how do you get the freshest data through some model, simulation, computation to make the best decision at the time that is closest when it is most relevant. And that's sort of the game, whether you're talking about algorithmic trading or other forms of automated trading. The key is to be able to work on current data because the market does swing, it moves real time. It really does move real time. And so the question is, and in scientific simulations you also have to model real time, but you don't make a decision on that data that is very important, actionable. People make a lot of money or lose a lot of money on those transactions. So if you take a look at what we're trying to do with our high performance computing platform, what we're really trying to do is ask, how do you get more analysis, more computation, more simulation done in a small amount of time? In some senses, the inevitable trend in hardware architecture is also forcing this because we don't get new compute power anymore in the form of faster clock speeds. For years, Intel just kept doubling clock speeds. Now they don't double clock speeds anymore. They give us twice as many cores or twice as many processors. And so figuring out how to take any application and parallelize it so it can run across multiple cores will be a key, not just in high-performance computing, not just in financial scenarios, but it'll be a key to, in all applications, figuring out how to continue to exploit the additional power that physics is giving us, essentially, that Moore's Law and the physics behind it is giving us. So I would say our basic computing strategy has to drive us in a direction that is consistent with our high-performance computing strategy, which is consistent with the kinds of strong needs for real-time analysis and decision-making on large data sets that's fundamental in automated trading approaches, algorithmic or otherwise.
What is Microsoft's kind of stance, with the new products as a software company? What is your strategy for capitalizing on these advancements in hardware?
Let me say two things. First of all, I think in high-performance computing specifically, one of the problems has been nobody's really standardized the hardware and software platforms. And so everything is roll your own. And because of that, everything is higher cost. It's higher cost to decide what to do it, to put in place the management infrastructure. The desktop's been standardized, the server's been standardized, the high-performance cluster has not been standardized. That doesn't mean there shouldn't be innovation, but the notion that everybody gets out and rolls their own is next to crazy. Now, we don't build the hardware, but we can be a factor in that because we have come with a standard compute cluster environment that we want to host on top of that hardware. And there's sort of a virtuous cycle like there is between Windows and any other hardware. So really getting our compute cluster stuff done, really partnering with the key guys on the hardware and infrastructure side is a key step. Second key step is this thing I talked about with respect to sort of the basic direction of chip architectures. We're trying to work with Intel and AMD and shape the way they give us many cores so we can take advantage of it, and they're trying to work with us to make sure we do the work in the operating systems, the compilers, and every place else, so that basically the kinds of guys who write applications can do that with some fluidity, with some accuracy, and without a lot of complexity. And today, writing these kind of parallel threaded applications is very hard. Part of our goal has got to be to make it very easy between what we do in the runtime and in the development tools and compilers.
Is there anything specific about the demands of the financial services industry, the needs that you're filling for the financial services industry that's dictated your strategy for getting your products on Wall Street? I mean, as opposed to other industries?
Sure. No, there's a lot of unique requirements that come out of and I can talk here if you like, mostly about capital markets firms, because the truth is there are also a unique set of things that come out of particularly retail banks because of the just sort of the branch nature and the management and operation that involved. On the capital market side, you get driven in a few places. There's more bespoke development in capital market, bespoke meaning people do more of their own custom development in capital markets firms than any other industry. Any other industry. Telco would probably be second, but financial services would certainly be number one. So we get a lot of push on developer productivity, developer tools, etc. Because there's so many applications, it also means there's so much computing and file system resource. So management becomes a more tricky proposition. Not because management's any different in financial services firms than it is in other firms, but you just get so many more servers typically in a financial services environment to run all of these bespoke applications. We've gotten a very distinct set of requirements that have come out of that process. There's been greater use of other non-Microsoft new technologies as well as Microsoft new technologies in financial services, so we get pushed harder and sooner on interoperability requirements. And when we announced our partnership, technical and IP interoperability with Novell, of course, we had somebody from the financial services world, Randy Cowan at Goldman, came and spoke at our event precisely because this is an important topic in a fairly interesting and unique way for capital markets firms. On high-performance computing, when we wrote down the list of industries to get after, pharma was certainly on the list, and oil and gas was on the list, but financial services was also very, very much on the list as sort of an early place to really get after and get lead customers and get the feedback on our high-performance computing strategy. We get a whole set of requirements for Excel from capital markets firms that don't look anything like the requirements we get from most other. I mean, there's scientists give us a set of Excel requirements, capital markets have another set of requirements, and then the rest of the world almost has a different set of requirements.
Financial services firms, and especially capital markets, are really like to be on the leading edge, and they do adopt new technology. But they have legacy systems as well, and to what extent are legacy systems an obstacle to realizing the benefits of high-performance computing?
In a way, the answer is not at all. I mean, frankly speaking, and it's almost easier in financial services is the easiest industry we deal with on this. Not because financial services doesn't have legacy systems, but the sort of gestalt, the mindset in financial services always, we're going to be writing 20 new applications this year anyway, and we can't take down most of the legacy applications. So there's always new activity, as opposed to industries where they say, hey, look, we just really don't want to write new apps. We're going to just keep bolting on and bolting on and bolting on. So it's almost harder for us to get any of our technology interjected. It's almost easier in financial services as long as we have a strong interoperability story, because the mindset is, yesterday's application I'm going to leave, but tomorrow's application exists. And so in a sense, there's almost a faster pace, particularly in capital markets now. I'd say this is less true in insurance and certainly in retail banking, but particularly in capital markets. The bad news is stuff doesn't go away, and so we don't get to replace it. The good news is there's always so much new stuff coming on stream that there's a real chance to play.